Hello, everyone that is joining us right now. I'm watching the numbers tick up, so we'll just give another minute here before we start. And again, thank you to our 2021 sponsors who are listed on this slide. Again, we'll start in just 1 minute. All right, welcome everyone. I'm still seeing the numbers tick up, but we'll get started here right on 7 at the dot. My name is Hannah Mortensen, and I am the Executive Director of Physicians for Social Responsibility Wisconsin and the Wisconsin Environmental Health Network, commonly referred to as WHN or WEN. WEN is a group of health advocates that are concerned about how environmental toxins and climate change affect our health. They are advocates, they provide educational materials and events like this where we can talk about issues and learn together. So that is WEN. And again, we're so thankful for our steering committee that is listed here. Very thankful. And now we're going to quickly turn over to our intern, Marina, who's going to share a little bit about the housekeeping for tonight's Zoom webinar.
Hello, everyone. Welcome to our second event in this series. Just so you know, throughout the webinar, only panelists are going to be visible. Attendees cannot be seen or heard from, but we also welcome your questions throughout the presentation, and we'll do our best to address them at the end of the presentation. So you can ask them at any point during the presentation. If you are joining us through Zoom, you can go to the Q&A at the bottom there with the green box around it and type in your question. Or if you are in the YouTube live, you can submit a comment. If you are calling in via phone, you can email us at wehnmail@gmail.com. And then if you would like to change your view of the presentation at any time, you can go in the upper right corner and select that view button, little view button, and choose speaker or gallery mode. And so if you want to see the slide up closer or not, you can toggle with that a little bit. And again, if you have any questions throughout the presentation about logistics, feel free to email us. I will now hand the floor over to Beth Neary, who will introduce tonight's speaker. Beth, you're muted.
Okay, all right. Good evening, everyone. It is my pleasure to introduce our speaker tonight, Dr. Linda Birnbaum. She is both a toxicologist and a microbiologist. She received her MS and PhD from the University of Illinois. She has had an illustrious career in environmental health. I'm just going to hit a few high points. She served as the past president of the Science Society of Toxicology. She worked at the EPA for 19 years. She has authored over 1,000 peer-reviewed publications which focus on pharmacokinetic behavior of environmental chemicals and their health effects. She is well known for her research on endocrine disrupting chemicals. She has received numerous awards and honors. Most recently, she was the director of the National Institute of Environmental Health Sciences and the National Toxicology Program, all part of the NIEHS. She continues as a scientist emeritus at the National Institute of Environmental Health Sciences, as well as a scholar in residence at Duke University. So on behalf of everyone in attendance, I offer you a warm Wisconsin welcome.
So, very much looking forward to this, and I am ready to share my screen. I think it's already up there. So thank you very much, Beth. That was a wonderful introduction. I really appreciate it. And what I'm really hoping to do today is kind of give you almost a soup to nuts version of PFAS, talking about the sources and the exposure and the potential health effects that there are and what we know about that, and then a little bit about regulation. But before I really get started on that, I just wanted to do a little Wisconsin specific information, since that's where we are. And I thought this was a pretty important picture just showing you the contamination that we have of water. This is a picture of what the foam that you get from these chemicals, which are known as forever chemicals, because in fact, they're extremely persistent in the environment. We have no evidence that they will ever totally go away. And then this is just a slide showing about that there are at least more than 30 sites that we know are contaminated with PFAS in Wisconsin. That doesn't mean there aren't others. It means this is where somebody has looked. And many of these sites are adjacent to known either defense sites, either current or former, or some of them are related to airports because of some of the material that was used there to suppress fires, and some of them may be related to manufacturing facilities. So just a little bit of background chemistry, and forget the number that you see at the bottom right there. This slide is maybe a couple of years old, but we now know that EPA even says that there are over 9,200 different PFAS. And the important thing about the PFAS is they all contain, for example, these are carbons and the green are fluorines, and it all contains those bonds. This is not a bond that normally occurs in nature. There is no easy way to break these bonds, so these basically stay together forever. And most of these are some of the legacy PFAS. I'll talk about some of the legacy effects and then also what we know about alternatives. But these are not so much PFOSA, well, a little bit, but these are all called long chain PFAS because they have enough carbons in it that, again, that they are very persistent, not only environmentally, but biologically as well. So you can look at all the different structural classes of PFAS, and this is a slide that my friend Ian Cousins shared with me. And I think one of the things, look, is there are all these different classes, and I don't expect anyone to measure laundry lists or stuff, but you've got, for example, the PFCAs are the carboxylic acids that I showed you pictures of. And then you have also those that have the sulfonates on the end, the PFSCAs. They can be more complicated than that. I'm going to come back to fluoropolymers in a minute, but then you have many others, for example, that have ether linkages. And some of their ways that we can group these, and I'll talk about that again later, is that we can talk about the fact that some have global warming potentials, things like the fluorohydrocarbons. Almost all of them are extremely mobile in the environment. All of them are persistent, that whole bubble there. Many of them we know are toxic, and many of them are bioaccumulative. So I think a point I want to make is that there are new PFAS that are found all the time. And this is just some data coming from New Jersey and the Office of Research and Development of EPA, where they collaborated with the Department of Environmental Quality in New Jersey. And there's a company called Solvay. You may not have heard of Solvay, but in fact, they are also a major producer of PFAS chemicals. And this was reported in Science last summer. And this is what we would call a chlorinated, see the chlorine atom, and all these oxygen atoms, which are ether bridges. And these chemicals would be a chlorinated PFICA. So it's got the acid at the end. It's got all these carbon fluorine bonds, but connected by oxygens. These molecules do not break down either in the environment, which makes them part of the whole PFAS class. And in fact, although these were produced and unfortunately contaminated various sites in southern New Jersey near where they were made, they've been found so far as far away as New Hampshire. So these chemicals, as I said before, are mobile and move. So how are we all exposed to PFAS? Well, a point that I should make is that these are very useful industrial chemicals. As I said, they don't really occur in nature, but in fact, they are produced industrially for a lot of use in consumer products, and I'll give you some examples in a moment. And they're also for fire suppression. So you have the air film foaming, let's just say AFFF. And this is what has been used extensively at airports. This has led to a tremendous amount of contamination of both drinking water and groundwater. The industrial use has led to presence in waste and in the waste streams, and again, contamination of the environment. All of the environmental contamination for example, can lead to a human exposure, as obviously as well as wildlife exposure. And I think it's important to realize that these chemicals are readily transferred across the placenta and are present in cord blood of the infant, and that they are also present in breast milk and transferred to the nursing baby as well. So how are we all exposed? Well, as I said, these are a very diverse group of chemicals, over 9,200 of them, which are used in industry and consumer products. I think a point I'd like to refer you, there was a paper published last November by Glug et al., and this group identified over 200 different types of uses of PFAS. So I've mentioned some of the products which you find them in, such as carpet and fabric, different kinds of paper used to package food, pots and pans. There's a nice picture of your Teflon pan. Here's some stain that gets on something, but things beat up because Scotchgard or something similar was used. They're used on clothing and cardboard packaging and in the firefighting foams. And the way we get exposed is all of our traditional routes of exposure. So dermal exposure is probably the least important because these chemicals can be taken up a little by our skin, but not a lot. I should remind you that anything gets on your skin also ends up getting in your mouth. We know that they can be inhaled, and we know that we ingest them not only from drinking water and from certain kinds of food, but also they're present in house dust as well. And when you inhale dust, some of it actually ends up being swallowed and so gets ingested. And it's not only infants and toddlers that this applies to. So where do we have all this water contamination? Well, the Environmental Working Group released another report a couple of months ago where they estimated that over 200 million Americans are drinking water which is contaminated with this class of chemicals. And this map just shows you the sites we know of, military sites, drinking water sites, and other sites throughout the country. And I should just point out, like if you look at my state of North Carolina, I can get my arrow to go there. Well, anyway, the point is that North Carolina is pretty blue. That's because we've had major contamination here, so there's been a lot of investigation. If you go to some place, for example, like Texas, you don't see so many dots, but that's because it hasn't been looked at very carefully. So in other words, this is what I would say is a minimum, not a maximum, of the locations that are known to have PFAS. And there's a lot of PFAS that have been identified in sites in Alaska, in part because of all the military history there. So I think one thing that's, where do we find the PFAS in, say, the water, either groundwater or drinking water? Frequently it's because it's adjacent to a production or use site. So if there's a site where they're making or using PFAS, you'll find higher levels in the water there. If it was a military fire training area or a domestic airport, you'll find higher levels there. And for example, we are also finding high levels of PFAS in wastewater treatment plants. And be happy to answer questions later about our biosolids and how contaminated they are turning out to be. So how are we being exposed? Well, I've told you that there's a lot coming out in different water. And in fact, this is an interesting study that's being conducted in the area of Colorado Springs, where the U.S. Air Force Academy is, as well as Peterson Air Force Base. And what you find here is that in this area, these are blood levels that were taken from a study that the University of Colorado is conducting. And what you can see is PFHXS, which is often the PFAS found at high concentrations in the AFFF. There's over 1,000-fold increase in the levels of PFHXS in serum of people drinking water in that region. PFOS is also elevated, but not as much. And sometimes PFOS is used in AFFF. Sometimes PFOA is used, and there's a slight increase. PFNA is not used in it, and you do not see any elevation in that. And this is compared to a reference mean from a similar point in time of sampling from the NIEHS National Biomonitoring Report Card. So I just thought this was an interesting set of slides coming out of Sweden. And this is looking at an area called Ronneby, where there is heavy AFFF contamination in the drinking water there because of the use of AFFF in that area. They have a lot of PFHXS in this population. But what I want you to know, the reference group here, note the scale on the y-axis. You know, we don't even get up to 30 parts per part trillion here. And what do we see in the population? In the red and the blue are men and women. But what you can see is it's not all that different. But what you see again is instead of a high of 30, we have some people with levels in the range of 2,000 parts per trillion. With the median is around 1,000 parts per trillion. And we do see an age-related increase with a chemical like PFHXS, or this is actually the sum of PFHXS, PFOA, and PFOS, which are all highly biologically persistent and bioaccumulative with half-lives in the neighborhood of 2 to 6 years. So they hang around. So I've shown you that how, for example, in areas where there's AFFF contamination of the drinking water, the contaminants get into people. Well, the same thing is true with PFOA, which is a legacy PFAS, which we'll talk more about, and is ones that all of us have all these chemicals, but PFOA, a lot of work has been done with this. And what you can see, the difference between the yellow and the blue bars are just the blue is mean water ingestion and the yellow is for people who drink more water every day. But you can see as the drinking water concentration goes up, so does the serum levels. So I think that it's important to realize you can actually make a rough calculation. If you know, for example, that your drinking water is 100 parts per trillion, if you multiply by about 200 to 200, you'll be in the ballpark of what your PFAS levels are in serum. So I mentioned the contamination in my state of North Carolina, and I'm just mentioning that because I think there's some other take-home lessons here. North Carolina, there was first discovered the contamination here by this point C, which is the city of Wilmington, a city of about 250,000 people at the mouth of the Cape Fear River. And their municipal water supply was found to be contaminated in about 2017 at the same time that the contamination was observed in the Cape Fear River. And what the contamination there is if you can see this chemical called Gen X, you can see the oxygen in the middle of it. So again, this is a PFAS chemical. And this was a substitute for PFOA. And what we found, or what's been observed, I should say, is that the PFOA was actually being dumped by Chemours, which was a spin-off chemical company from DuPont, into the Cape Fear River. When that was discovered, the North Carolina Department of Environmental Quality finally forced Chemours to stop dumping it, so the levels did drop in the drinking water of people downstream. But if you look on that little diagram of North Carolina, it's the going up to Greensboro, which is about a 200,000 person city upstream. And in fact, there's contamination all throughout the area. And some of it we now know comes from an airport near Greensboro. Some of it comes from contamination from municipal wastewater treatment plants, leading to heavy contamination going down the river. So if you look at the graphs on your left, the points that I want to make here is what you can see is that the closed bars are the levels in people in Wilmington. The open ones are the ones for people in Haines. And what you can see is the people in Wilmington have higher levels than people statistically based sampling of the American population. And if you go to the 4 graphs on the right, this is actually at a site. Wish I could see where my there's my arrow. This is at a site right here, which is where the Haw River goes into the Cape Fear, and there's a town right about here. It's called Pittsboro. And unfortunately, the municipal wastewater treatment plant coming out of the city of Burlington around here flows into the Haw River and has led to levels as high as 1,000 parts per trillion of PFAS in the drinking water for people in Pittsboro. And we see the same thing in people in Pittsboro that we do in people in Wilmington. That again, if you compare the dotted lines are the levels in Wilmington. The 2 boxes are 2 sets of samples that were taken at 2 points in time in the people in Pittsboro. But what you can see, just like in Wilmington, their PFOS, their PFOA, their PFNA, their PFHXS are all elevated in the population. So again, this was not due to chemours. This is due to other non-point sources upstream. So where else are we getting PFAS for? It's not only our drinking water. It's not only in some of our agriculture from the use of biosolids on crops and forage, but it's also from fast food packaging. So there have been several studies now that have looked at the PFAS and fast food packaging, and what you find is that there's a significant amounts of PFAS in certain dessert and bread wrappers and sandwich wrappers and paperboard. Luckily, it hasn't been reported in paper cups. I should say, when some of these studies first came out, Whole Foods was very upset to find that their clamshells were heavily contaminated. They immediately got rid of them and found a supplier that didn't use PFAS in their paperboard. And McDonald's has just announced that they will be removing all PFAS from their food packaging within the next couple of years. Now, we know that people who eat more fast food, there are studies showing that they have higher levels of PFAS, but all of us have PFAS in our body. In fact, they're detected in humans around the world. We know, for example, one thing that I think is important to point out here is that PFOA and PFAS were voluntarily or negotiated removed from production in the US, PFOS in about 2002 and PFOA much more recently than that, about 2013. And what you can see is these are, again, data over time up through 2014 and NIEHS. And what you can see is that the levels have come down for these two, but no change for this is the 10 carbon acid, and this is, we've mentioned PFHXS before. And I would actually suggest that what we're seeing now is that these levels are leveling off because we're beginning to get reentrainment of these compounds in the environment and therefore uptake into our bodies again. So I think an important kind of thing to be aware of is we really don't have good information of where these PFAS are in our body. We have some data for PFOA and PFOS based largely upon rodent studies. This is the only study that I know of that came out in 2013 from Barcelona. And what you can see here is that all these PFAS aren't behaving the same way in the body. So for example, you see PFOS, you've got fairly high concentrations in the liver, certainly kind of comparable or a little bit lower than in the kidney. But look at PFBA. PFBA is one of these newer, which I'll talk about more, short chain length PFAS. It only has 4 carbon atoms in it. It looks like PFOA, which has 8 carbons, but this only has 4. And look where it concentrates, high concentrations in the lung. When you look at something like the C6 in this series, C4, C6, C8, PFHXA, where do you see high concentrations of that? Some in the lung and lots in the brain. So I think these are some studies we really need a better handle on where some of these newer PFAS are actually going in our bodies. So this is just kind of a timeline showing you some of the what's going on. PFAS were first created. Teflon was invented in the 30s, began to be used in the 40s. And frankly, by the 50s, there was lots of production of PFOA and PFOS-based products that were being used. The first some of the first evidences of problems, I would say, is when they found PFAS in workers in the DuPont plant in around 1980. And then by 1987, the industry had studies showing that PFOA actually was carcinogenic in rodent studies. And let's see. For example, in 1962, there was an internal memo in DuPont that Rob Billet found where people in DuPont raised concerns about the health of PFAS, but that was never reported. And then around the time they first detected PFAS in serum of workers, they began to observe birth defects in children of women who were working on this was in, especially in Parkersburg, West Virginia, on the PFOA line. And then as time came on, certainly by 2000, again, essentially all Americans had PFAS in them and 3M said they were going to stop making PFOA, and then they stopped making PFOS. DuPont actually got sued in a class action lawsuit, which ended up eventually being settled and providing one of our most important health studies of PFAS. And then as DuPont and 3M started coming up with substitutes. So Gen-X was a substitute for PFOA, and something called Adona was a substitute for PFOS. And again, these were things that were called short chains, and they're PFICAs, and we now know they never break down either. So this is just some information about, this is a quick snapshot of what's called the C8 study, which is that PFOA study that Rob Billett was the lead attorney for. And this was based upon the DuPont plant in Parkersburg, West Virginia, where huge amounts of PFOA were dumped into the river and the water supply, contaminating the water supply of quite a number of communities along the river, including Little Hocking and Parkersburg itself, where the plant was, and so on. Rob was able to, well, I should say, a settlement of the court. The judge said that they appointed a 3-scientist panel to oversee the conduct of a major epidemiology study looking at the levels in people in this area and the health effects. And they concluded, after recruiting over 67,000 people from this area, that there was pretty much very high evidence of associations with both testicular and kidney cancer, with hypertension, both in adults and involved during pregnancy, that there was the autoimmune condition of ulcerative colitis and the liver effects of high cholesterol. There were many other health effects that were associated, but these were the ones that were absolutely, I would say, a red flag waving about them. So some recent data also looking at some of the immune effects of PFAS is my NTP conducted a systematic review that was peer-reviewed and published in 2016 of where they looked at all the animal and the human studies that existed up till that point in time, looking at immune effects. And what you could clearly see is both in animals and humans that PFOA and PFOS were immunosuppressive, and also introduced both in animals and people hypersensitivity. And there was also the evidence of autoimmunity in people. Some of the real importance of this goes on with the data that Philippe Grandjean and co-workers have been working on in the Faroe Islands and other locations for years now, where they've recruited birth cohorts and looked at the early life exposure that children had and measured their response when they got their immunizations to diphtheria and tetanus and others. And they found that basically, there was a reduced ability to mount a therapeutic antibody response, so much so that about 20% of the population would not have enough antibodies to be able to resist an infection, for example, with diphtheria or tetanus. Just a few months ago, in another study that came out of Gambia in West Africa, they showed that there was a decreased vaccination response to measles in children associated again with their early life exposure. And then this has consequences and has been shown in a number of populations in Norway, in the Faroe Islands, and in northern Japan, that children whose mothers had higher levels of PFAS have an increased incidence of respiratory infections. So the suppression of the immune response has consequences. And one point I wanted to make is this is some very new data, again, coming from Philippe is actually Danish, and he was in Denmark when the pandemic broke out and has not been able to return to the US since then. He normally spends half his year at Harvard. But anyway, he was able to collaborate with some folks at a hospital in Copenhagen and look at get blood samples from people who were hospitalized because of COVID. And what he saw was a clear dose response relationship between the severity of the condition, so that people, for example, who were who had very little hospitalization had lower levels of PFBA than people with longer, or those people who actually died. And I think what's interesting is that this association was clearest for PFBA, which is that 4-carbon relative of PFOA, one of the short chains, and this is the one that appears to concentrate in the lungs. And we know that lungs are a major target of the SARS-CoV-2 virus. So there are a number of other studies that are going on right now in Europe and in the US, where people are asking the question, is the incidence of COVID higher, as well as and also is there an increase in severity related to PFAS exposure? So I think we stay tuned, might see some interesting data coming out there. Well, some of the other health effects that PFAS has been associated with, and there are a number of studies showing PFAS association with obesity, but also diabetes, both gestational diabetes, and this is looking at some of the individual PFASs, the 4 I've talked about before, and for example, with type 2 diabetes, and this is specifically looking at PFOS, that you do see an increased odds ratio, a significant increase with an odds ratio in the neighborhood of close to 2 in this study that I'm showing this data from here. Now, in addition to, I mentioned that there was an association with obesity with PFAS. This is some data showing with PFOS exposure. And what we see here, for example, is that for women who had higher PFOS, they had larger gestational weight gain than people who did not have elevated PFOS. And I'm going to come back to that point later because we actually have animal data that shows the exact same impact. The graph on your right is actually showing an impact on cognitive function in children. This is related to the serum PFNA here, that's the C9 compound. As that level goes up, the children are more likely to be associated with 3 different measures of executive function. And this doesn't go away, but in fact gets much stronger as the children age. So we understand that impacts of exposures that occur early in life have long consequences. And this is another study looking at different measures of adiposity in infants and how they grow. And one point I want to point out here is that these kind of chemicals, the PFAS, are endocrine disrupting chemicals, so we should not be surprised when we see big sex-specific differences. So in this case, blue are the males, and what you can see is PFNA and PFOA are causing a great obvious increase in adiposity, and you do not see that in the little girls at all, the baby girl infants. And if again, you can see a repeat of this looking at this other measure. And again, so you've got the mother's levels associated with adiposity, especially in the little boys. And in fact, we see this same, let's say, male-specific impact or greater impact in the males if we look at their size when they're born and their birth weight or their head circumference. And you can see here a decrease. The boys have a significantly lower weight when they're born. And PFOS is a driver there. It's also related to a decrease in head circumference. But when you pool these for PFAS, what you find is a much stronger effect. So the importance of that, we really need to look at these PFAS, not one at a time, but in combination as well. And then this is some data coming out of another cohort that's been followed for over 20 years in Ohio. And this cohort, it's not the PFOA cohort, it's actually at a cohort that's being followed at an area where they were working with radioactive materials. And what you can see is that PFOS and you can see this throughout the studies, that certainly in the last 10 years, there's an increase associated with TSH, which is thyroid stimulating hormone. TSH goes up because the thyroid gland is having trouble making enough of T4 for the body. So an elevated TSH means there's perturbation of the thyroid. And then they also show that for several other the PFAS, the PFNA, the PFHXS, the PFDEA, that's the C10 relative of the C9 or the C8. And there's a decrease in the glomerular filtration rate, which is a decreased kidney function. And these effects have been reported in a number of studies. Another important thing here is the extreme stability and persistence of PFHXS in this population, where the levels over a 10-year period didn't change very much. And we know it's got a long half-life, but it also says there's ongoing exposure. Another point I wanted to bring up is there's data showing that for women who are more highly exposed to PFAS, they appear to nurse their babies for a shorter amount of time. So in this study, compared to those women with the lowest in the first quartile, they nurse their babies for a longer period of time than, for example, women with some elevations in their PFOA was looked at here. In this study, they looked at several different PFAS, again, the C10, the C9, the C8, and then the PFOS. And what you can see, there's even a suggestion in the PFHXS, but these are all highly significant decreases in the length of time of lactation. So PFAS, I hope I've shown you that these are multi-system toxicants. They do lots of different things in many, many different kinds of tissues and organ systems, and they do it developmentally as well as in adults. And I think that's something that we need to be very cognizant of. So I've mentioned the PFAS, PFOS, and PFOA replacements, and I think we need to ask the question, are they safer? Well, I've already mentioned to you that all of these are extremely environmentally persistent. As far as we know, they will all be with us forever. We have some data on the toxicity, say you have to drink more water or eat more contaminated food, but once it gets into you, it does the same thing, and I'll show you some data for that. For water filtration and remediation, I think it's important to realize this, and this is some data from Heather Stapleton's lab at Duke. She's looked at different kinds of ways to get it out of your drinking water. And in fact, granular activated charcoal has been used, and it works pretty well for PFOA and PFOS, and the other long chains does not work well for the short chains. Anion exchange works a little bit for the short chains, but doesn't work well for the long chains. The reverse osmosis or nanofiltration works quite well for both short and long chains. This requires a lot of energy. And in all cases, what do you do with the concentrated material that you pull out of your drinking water? I should also mention the GAC is probably what many of you have in your refrigerators. If you have a filtration system in your refrigerator, and I would urge you to change your filters about every 6 months. But the reverse osmosis is much more expensive. And you also, again, will need a lot more energy to run it. So what are some of the effects of the short chains alternatives? The only data we have to date on effects are in our experimental animal models. We know that, for example, the fluorotelomere alcohols like the 6,2-FTOH, there were many of the fluorotelomere alcohols and carboxylic acid and sulfonic acids. And guess what? They get metabolized to branch chain compounds like PFOA. And these compounds are highly persistent and toxic. These are some of the carboxylic acid and sulfonic acid fluorotelomeres. And again, these lead to the effects not only of kind of gross toxicity, but inflammation and cell death in mice. PFBS is a C4 relative of PFOS and PFHXS. PFHXA is the C6 relative of PFOA. These all do exactly the same thing. They lead to increases in liver weights and liver lesions and increases in specific enzymes. They really have not been studied extensively beyond that. Gen X, which I've mentioned, is the major contaminant in North Carolina. And this does exactly the same liver effects and breast effects on the developing mammary gland that PFOA does, but at actually lower internal concentrations. This is the data on the mammary gland that I wanted to show you. So this is at puberty, or just around the time of puberty. These are mouse. These are data from a squash preparation of the mammary gland, and you can see at this point you've got a pretty developed ductal structure in the mammary gland. Well, guess what? This is PFOA, and this is Gen X. And these animals were exposed in utero and lactationally to PFOA and Gen X. And what you can see is you have a much less dense ductal tree, which will mean these animals have more difficulty in lactating. And I showed you the data that we have from the epidemiology studies suggesting that women with higher levels may not breastfeed as long, potentially because they're less successful. And this is the data showing you actually the level for the scoring of how developed the mammary gland is. And what you can see is this dose-related increase in the problems with PFOA. And if we look over here, we have the data for Gen X. And essentially, we see exactly the same thing as we do for PFOA. And actually, here, the administrative dose, we know the liver concentrations are actually higher from Gen X. And what we see is the administrative dose and the response are essentially the same as PFOA. So although you may be told that Gen X has a short half-life, and it does have a shorter half-life, it still can cause its effects. The effects of Gen X, which the chemical is often called HFPODA, the dimer acid. This is work that is in rats that was done at EPA's research labs in North Carolina. And at this point, they were looking at pup survival. And what you can see here is if you look at an oral dose, it looks like you got to use a lot more Gen X to impact pup survival than you do PFOA. But if you actually measure what's in the serum, if you do it on a parts per a billion level, what you see is they're pretty much the same, or in fact, maybe Gen X is a little more potent. If you then put it on a molar basis, what you see is they're really very, very similar. And I think that's shown down here in actually measurements of the serum concentration, either in parts per billion or in molar levels. And again, so what you see is that actually in a serum concentration, the Gen X is more potent than PFOS, and also a little bit on the serum level as well. So a point that I'd like to make now, Beth knows me, I think, from my dioxin days, which I still do play around with. And when I used to say dioxin is the most toxic man-made chemical ever known, but dioxin has a single initiating mechanism of toxicity, which is binding to one specific receptor, the dioxin receptor. That is not the case for PFAS, which activate multiple receptors, at least two different PPARs, two different forms, an alpha and a gamma form. I should say the alpha form is related to lipid metabolism, and the gamma form is related to adipogenesis and osteogenesis, and then other receptors. So the H receptor, CAR and PXR, and this is the fatty acid receptor. In fact, there may be as many as 14 different nuclear receptors that can be activated by PFAS. And some of the clear mechanisms involved inhibition of fatty acid transport and interfering with mitochondrial function. So very complicated mechanisms exist. So what are some of our main research questions that we should be thinking about? Well, first, I haven't really pointed out to you very much, but there's lots of PFAS in all these samples, and we have no idea what much of it is. So in the Cape Fear River, for example, EPA was able to show that they could only identify about 25% of the total PFAS in the waters that they were looking at. There's also data from some limited data from other studies in serum, but we really need to know, are we measuring 10% of the PFAS or 90%? So we need to do some measures of total organic fluoride, for example. We really need to begin to say, where do we really need these chemicals and where can we replace them with safer alternatives? And I'm going to stress that because we have a history of unfortunate substitutions. So we want to make sure any substitutes are safer. And how are we going to approach these? I was co-author on a paper that was published last summer talking about regulating the potential to regulate PFAS as one single chemical group or possibly a limited number of subclasses. And this goes along with a recent recommendation from the National Academies of Science, Engineering, and Medicine that an approach that uses subclasses to assess chemicals is certainly scientifically justifiable. So what about federal regulations? Well, guess what? EPA has not regulated any PFAS, and I think we need to understand that. Although they came up with a lifetime health advisory of 70 parts per trillion of PFOA plus PFOS in 2016. They have not been able to propose regulations for those yet. They recently proposed a regulation for PFBS, which the Biden administration immediately voided because there had been interference with the scientists by political appointees in that document. There's no regulation of drinking water, groundwater, and President Biden has committed to getting PFAS listed as hazardous substances, which would be very helpful to the states. In the NDAA, the National Defense Authorization Act, and in the 2020 legislation, EPA was finally required to add 172 different PFAS to their yearly toxic release toxic release inventory. FDA has been dealing with food contamination. I'll come back on that with them in a moment to a certain extent. The Department of Defense, since 2016, has not been using AFFF containing PFAS in any practice fire training, but only for actual oil and grease fires. But they are required by 2024 to stop using any PFAS containing AFFF. And because of the NDAA, they are now blocked from purchasing any food material that comes in PFAS containing food packaging. This will have a huge impact on how the marketplace responds. CPSC is looking at some regulations, and the Federal Aviation Authority, in their reauthorization in 2018, were told that they no longer were required to have PFAS and AFFF at domestic airports. And as of near the end of this year, they can no longer use it, even if they have it. I think it's important to understand is that PFAS containing AFFF is banned in 180 countries, not the United States. So our states are the ones that are moving ahead. California EPA just last week, that should not be 2921, that's a little in the future, just last week published a paper recommended regulating PFAS as a class in consumer products, saying it's logical, necessary, and looking forward, and it will be helpful to other regulatory agencies. This measure, I could say, as California goes, so goes the nation. 11 US states are now considering banning PFAS in food packaging. Currently, 3 states actually do: New York, Maine, and Washington. 20 states are looking at policies involving more than 180 bills focusing on PFAS, and several major grocery and restaurant chains have announced the policies to reduce or eliminate PFAS and other chemicals in food packaging. So what about drinking water standards? Well, here's EPA's lifetime advisory, not a standard. And here are the states that actually have regulatory numbers and are actually regulating levels for sometimes PFOA and PFAS. Sometimes, for example, Massachusetts is regulating for the sum of 5 different PFAS, a total of 20 parts per billion in the sum. For example, Vermont is regulating for the sum of 5 PFAS. New Jersey has and Michigan have very low levels where they're regulating individually for PFOA, for example, and PFOS, and actual PFOS and PFNA as well, PFHXS too. So again, our states are moving ahead in regulating drinking water. Very few regulations of groundwater at all yet. Yeah, sorry, I went backwards. But what about Wisconsin? Well, I want to commend the Wisconsin PFAS Action Plan, where there are 25 action items that are actually laid out. The recommendations of science-based standards for environmental media, improving the risk communications so that we can have a better website than in Wisconsin. You'd be able to get lots of information, will enhance public engagement. Really have to look at better processes for delivery of safe drinking water communities. And as I showed you in an early slide, there are over 31 known sites of PFAS contamination. And again, a lot of this is not only people in the area, but also veterans and their families who live near military sites that have a higher risk of exposure. So there's been a bunch of recent PFAS action in Wisconsin. I give Wisconsin kudos for leading a 22-state coalition that are looking and encouraging the federal government to develop standards in drinking water. And the state has actually sent the Department of Natural Resources groundwater standards of 20 ppt for PFOA plus, sorry, that should be PFOA plus PFOS, individually or combined. A company called Johnson Controls, which is near Marinette, has to pay the residents in the city there $17.5 million to settle a lawsuit because of contamination of their area from a plant there. And the governor just earlier this month announced that his administration is going to take legal action against commercial companies responsible for PFAS contamination in Wisconsin. And this is based upon the recommendation from the PFAS Action Council's PFAS Action Plan. And this morning, or I should say yesterday, was in the press this morning, the Department of Natural Resources actually has been sued by the state's largest business lobbying group about enforcement of the PFAS cleanup. In other words, the business group is not interested in doing the cleanup of PFAS. So I think it's important for us to be aware of some of the systematic changes that are happening worldwide. I mentioned that 180 chemicals have banned PFAS containing AFFF under most circumstances. So what's happening is we've got the purple is what the fluorochemical industry is doing, which is pushing back, but there's new evidence and we can develop new alternatives that are not PFAS kinds of molecules. We can look at formulations that don't involve the requirement for PFAS. In other words, focus on the solution, not focusing on the product. And we can make sure that we get these removed from many of the products, such as food packaging and textiles and cosmetics. Here in the US, Home Depot and Lowe's last year agreed to stop putting PFAS on the carpets that they sell. So again, and a lot of this is coming from groups like WEN, as well as other NGOs, consumer authorities, and will help us lead to PFAS-free products. So over 5 years ago, a group of over 200 scientists called on the international community to limit the production and use of PFAS and developing safer non-fluorinated alternatives. And in fact, the EU is way ahead of the US here, and they have a marvelous chemical strategy that was released in October. And in that, they explicitly call out PFAS. I think many of you know that the EU has a program called REACH, which requires chemicals to be tested for safety before they're released on the marketplace, which is not what happens here in the US, where we assume something is innocent until proven guilty. But for PFAS, this commission is calling for a ban in all firefighting foams and other uses, unless where they're essential. They're looking for a class approach. They're looking for, they're making up the point that this is an international problem, so we need to approach this in an international way. And I should say several PFAS are listed under the Stockholm Convention, which the US has never signed, and that we have to look at innovative methodologies to try to remediate the PFAS contamination that we already have. And we need to find safe innovations to substitute for PFAS. So I guess the question I'd like to leave you with is, why do we continue to make compounds that will never go away? I would have hoped we learned from compounds like DDE and dioxins and PCBs and brominated flame retardants that when we make things that don't go away, they last with us and cause problems for a long time. So thanks to all of you for listening. And I could not have learned all of this without my trainees and my collaborators, and especially my colleagues. If you haven't seen Dark Waters, I highly recommend it. This is the story of Rob Billett and what went on with DuPont and the Parkersburg, West Virginia area. But I'll be very happy to answer questions. So thanks very much for listening.
Thank you so much, Linda. I just want to give you a round of applause, and I hope you can imagine the sound of it all. Thank you for such a thorough presentation. I do want to remind people on this call that it is recorded. If you did miss a slide, if you did miss something, it is recorded. just FYI. And now we will start questions. So you can go to the bottom of your screen. If you make Zoom full screen, there's a Q&A box with 2 little bubbles, and that's where you can submit questions for us to be answered here. So I'm first going to call upon actually our other panelist, Beth Neary. She had a question right off the bat. Beth, go ahead.
Okay, great. Thank you, Linda. That talk was amazing. And thank you so much for bringing in the Wisconsin information. And as you know, we do have a major problem in northern Wisconsin, in Marinette, Wisconsin, where the Tyco's plant actually contaminated the wells of many people there, and they've been on bottled water for many, many years. So it was timely that you came today because of that case that showed up. But I do have a couple questions about that case, because what the WMC sort of hides behind is the fact that the EPA has not yet added PFAS chemicals to its list of hazardous substances. Number one, is that true? And
Yes.
how do certain states set up these regulations, and how can we deal with this lawsuit?
Well, let's go back to the hazardous. As I mentioned, President Biden has announced that he will see that PFAS gets listed as hazardous compounds. So I think you're going to see things coming from EPA within the next couple of months where that will happen. So if it gets listed as a hazardous waste, or as hazardous compound, that means the rules of RCRA, which are related to hazardous waste, apply. It will also mean it applies to Superfund. And with Superfund, that will now allow the states to really get busy in some of these areas. So that's encouraging. Your question was, what can the states do? Well, as I said, the states are way ahead of the federal government here in many aspects. With FDA has regulated at least the 6,2-fluorotelomere alcohol being used in food packaging, and 7 of the legacy PFAS. They can no longer be used in food packaging. That still leaves others that are being used, and they haven't regulated them yet. But we have at least 3 states which have a total ban on PFAS. The one in, New York goes into effect, was just signed in December and goes into effect in 2023. The one in Maine, I think, is in effect, and the one in Washington goes into effect in 2022. But there are 11 other states that now are looking at banning it in food packaging. And then, as I said, there are many other states which are moving on legislation to actually regulate it, and at least 7 states have developed drinking water standards, which are much more protective than what EPA has proposed as its lifetime health advisory. And it will be interesting to see under the Biden administration whether there is some urgency placed on this. I mean, EPA began assessing the risk of PFOA and PFOS in 2000, and we still don't have any regulatory limits. And as long as EPA once EPA sets the regulatory limits under TSCA, under the revitalization of TSCA and the Lautenberg Act of 2016, once EPA sets a regulation, states can't be more prescriptive than EPA is. Until then, though, they can make things that are more prescriptive, and then EPA can have something less prescriptive. The states don't have to respond at that point. So I think there's real advantages if the states can get some regulations into place sooner.
Okay, great. Here's a question that comes from one of my colleagues who's a perinatologist. And she said, given the evidence that PFAS concentrates in the breast milk, what are you recommending to women regarding breastfeeding?
That is a great question. And I'm going to, I can only defer to what we in public health, where we say breast is best. But I think people are beginning to wonder if there's a woman who has very high levels of these compounds in her body, in her serum, a way to get rid of them from her is to transfer them to her infant. And we have no evidence yet that if you'd want to do kind of a risk trade-off, are the babies who are, remember, they were also exposed in utero. Okay, so if there's damage, it may have already occurred, because many health effects, because of the developmental windows, where we know that for certain things, for example, the heart is fully developed, by the end of the first trimester. So you know, if there were PFAS, then what you get in breast milk isn't going to affect cardiovascular functioning, for example. The immune effects are late third trimester, for example. And there's actually a paper that just was published this week showing increased association of elevated PFOA and PFNA. First trimester elevations in that associated with an increased risk of miscarriage. So we're beginning to see things. So at this point, I would still say breast is best for women. That's assuming, you know, if they find that their levels are extremely high, they may have trouble nursing, because as I showed you, women with higher levels tend to nurse for a shorter period of time. And whether that is because they're having difficulty, because their breast during the what occurs during pregnancy, which is as it prepares for lactation, you don't get a normal development. We don't know the answers to that yet, but it's certainly a possibility. But it's what I used to tell people with the dioxins and the PCBs and the flame retardants. At one point, I felt super guilty that I had nursed the highest levels of dioxins and PCBs in most Americans was in around 1970s, 1980s. Well, that's when I had my babies, and I nursed all my children for a long time. And I'm thinking, oh my God, what did I do to them? But you know, you do the best you can. And so unless we learn something different, I still do think breast is best.
Okay, good. And here's a question from a water quality specialist. He said, are you aware of communities demanding that their water utilities test for PFAS and then install filtration to remove it? Because it's an environmental justice issue, because lower income families cannot afford RO systems, reverse osmosis.
Right.
What are your thoughts on that?
It absolutely is. It's not only an RO issue, it's a bottled water issue, right, you know, where they may not be able to afford it. And of course, where do we have problems where, for example, where do people live? It's often near fence lines. And I showed you that people living near industrial sites where there's manufacturing or production of PFAS or use of the PFAS, there's more contamination in the water around those areas. There's also more contamination, for example, in the air. There's studies now that show, again, coming out of North Carolina, that they could detect PFAS that were being emitted from the Chemours plant from 6 to 10 miles away. They could find it, for example, on the produce that was grown in that area. And then there are the episodes that have occurred in Maine and New Mexico, where the biosolids were spread on the fields, and the cows who eat a lot of grass and other things, you know, from the fields, ended up with and dairy herds that were contaminated. So their milk was contaminated.
Next question.
Sure.
Yeah. The next question is, how did they figure out that the North Carolina groundwater contamination was from 3 distinct sources? So, you know, this person's wondering what the tracers were, or how did they determine that there was 3 different sources?
Well, when the contamination was found in the Cape Fear in Wilmington, we knew that their drinking water came from the river. We knew that the river flowed right past the Chemours plant, which was actually a DuPont facility until DuPont spun off Chemours. And we knew what they had told us, or they told the Department of Environmental Quality, what they were making there. And you could see there were some compounds that are byproducts during the production of the polymers, that Genex is a processing aid used in the production of certain PFAS containing polymers. And there were things that were not intentionally made by Chemours, but were part of the process, so that you could tie it to that. When you go further upstream, you start finding, coming out of the Burlington, they've actually, the Southern Environmental Law Center has actually sued the city of Burlington because they've been able to show that their municipal waste treatment plant, the effluent coming out of that is very, very contaminated with PFAS. They don't know where it's all coming from. You know, Burlington has lots of small industries, a lot of textile plants, but they don't really know where it's coming from. They do know that Greensboro, some of the elevated levels there is the High Point Triad Airport, which is outside of Greensboro, that use the AFFF. So there are numerous sources, but many of the sources are not as distinct as an air, you know, a an airport site or a fire training site or a municipal waste treatment plant or a production facility. So like they think there, as I said, in Burlington, there may be 60 sites that are contributing to the contamination.
Okay, I'm going to try to combine a couple questions here. So Dr. Henry Anderson asked the question. He used to be our state health officer, and in combination with someone else. Do you think measuring total organic fluoride is worth exploring? And the second part is from another person who said, what about, and I know that you're a big proponent of the fact that we're testing these chemicals by themselves, and what we're exposed to is a cornucopia of chemicals. So what is it like if somebody has fluoride in their water and PFAS in their water and all these different things?
Okay, so Andy's question was the first one. I'm already forgetting what that exactly was. Oh, yeah, total organic fluorine.
Right.
I think with this, we need to be doing that. I think we need to have this handle, as I said in one slide. Are we measuring 10% of the PFAS in whatever we're looking at, or almost all of it? If it turns out that we're only measuring a small amount, what else are we being exposed to that we don't even know? And is that having adverse health effects? So I think it's very important that there are a couple of different approaches. There's something called the TOF, there's the EOF, I forget exactly the difference there. And then there's a method called PIGGY, which is a positron, X-ray positron approach, which looks at surfaces of materials. So it's, you can use it to look at, for example, some of your food packaging easily, if you're not dealing with something in solution. But there are a number of people who are looking at that. And then the issue of the fact cornucopia sounds much too delicious. You think of cornucopia as all kinds of wonderful food, but in fact, we live in a soup of chemicals, and not only the PFAS. I mean, you got lots of other chemicals in there. So yes, fluoride, but that's inorganic fluoride, which has very different effects than the PFAS and behaves very differently in the body or anywhere else. But then you've got all the other chemicals, you've got the phthalates and you've got the phenols like BPA, and we all still have chemicals in our bodies, and you've got metals. And there are a number of groups that are starting to try to approach this issue of how do we deal with the complex mixture. So there are, for some human studies, people are using some very sophisticated statistical techniques to try to kind of untangle things to a certain extent. But in most cases, people are just doing one at a time, or maybe sometimes 2 or 3 at a time. There are a number of groups that now are trying to push to have at least some animal studies or some high throughput screening kind of studies where you could make complex mixtures and assess whether the effects look to be additive or synergistic, for example. But it's a huge need.
Okay, this is a question about how do we dispose of this. So someone said, I have cans of Scotchgard, I have fluoridated ski wax. How do I dispose of this?
Well, that person with the fluoridated ski wax must have noted at my first slide where I had the pictures of the skiers. This has been a problem, especially for downhill skis and for your competitive skiers. But I think that those waxes are finally being withdrawn from the market. But it is the issue. What do you do with your stored stuff? Mm-hmm. What did I do when I got rid of my Teflon pans? Well, they basically went to the dump, but it wasn't a lined landfill. So stuff may eventually migrate out. I don't think we know now. I mean, I think with for example, your cans of Scotchgard, and I'm sure many people used to do what I did. I'd get a new tablecloth, and the first thing I do would be spray it with Scotchgard so it wouldn't get so stained looking. I think we need to obviously stop doing that and stop purchasing that kind of thing, but we really have no good disposal way. Just as I said, we really don't have any very good way to get rid of the PFAS, for example, that's in our drinking water, other than with a very expensive approach. And then you're left with a concentrated mix. What do you do with that? Mm-hmm. So it's a huge need to find successful ways that we can get rid of this stuff, but we certainly don't want stuff just being dumped places where it will then enter our environment and we'll get re-exposed.
Right. So all the information you gave to us sometimes can be overwhelming. So this person asked a practical question. What are the top 3 to 5 recommendations that you give to families to avoid or reduce exposure to PFAS? And what about distilled water?
Okay, well, distilled water, would it remove PFAS? It might. But distilled water, you got to be sure you add some really necessary ions that you need, like magnesium, or you could have problems. Most bottled water has very low PFAS. So if you have that option, if you have the ability to use filtration, while the carbon filtration won't get rid of many of the newer PFAS, it'll reduce it. So that would be an approach. And the carbon filters aren't nearly as expensive as the reverse osmosis. I know many people in our area have put reverse osmosis just under like their kitchen sink. They haven't put it in their whole house. And that may be a couple $100, but not thousands of dollars to do it. There are that town of Pittsburgh I mentioned, the municipal water supply there is looking at and putting it on their whole water supply for the whole town, because everybody getting their water is getting contaminated water. So if you ask me, what do I tell people to do? I'm a pragmatist. I do what I can, and it makes sense to me. So, I got rid of my Teflon pans, and I went to, there are a couple of websites that I think are worth looking at where you can get some information on PFAS-free materials. The Green Science Policy Institute has a really good website, and so does the Environmental Working Group, with recommendations and both warnings and recommendations. And I would tell you, if you go to replace your nonstick pans and you go to the store and you see all these pans with big signs that say PFOA free, that's a warning. Because if it doesn't say PFAS free, it means they didn't use PFOA, but it probably has Gen X or one of the other substitutes. So you got to kind of be a little careful there. I think you can, if you know your water is really contaminated, and of course, as I said, we really don't know that in many cases, if you can afford it, and that's a big caveat, you can use bottled water, at least for drinking, for example. I think, we can begin to use food contact material, or we can not put our food in kinds of, not store our food in certain kinds of plastic or paper, which has PFAS in it. And of course, I hope that nobody is heating their food in plastic. We've known for at least 25 years that that's something that we shouldn't be doing, not only because of the PFAS, but because of the phthalates and the phenols and everything else that will migrate into your food when it gets hot. But I think the market basket can be very powerful. And I think if people let manufacturers know, I don't want PFAS on my new hiking gear, and I don't want PFAS when I buy your food, I don't want it to be wrapped in PFAS containing things. I think the marketplace starts to respond.
Okay, good. Okay, we need a clarification. Somebody wrote this too. So 2 weeks ago, we had Arlene Blum speak.
Okay.
She said that she doesn't want you to buy Teflon pans because the problem is in the manufacturer. But she said the polymer is so tight that it's really not getting into your food unless your Teflon is scratched. Is that your understanding?
Or unless you heat your pans to high.
Like super high?
You put it on the high setting.
Yeah.
And then some of the PFAS will vaporize. And we've known for a long time that you better not have your bird in your kitchen if you're cooking with at least the old Teflon pans, because birds are exquisitely sensitive to the PFAS, and they'll die quickly from things that you wouldn't realize that you had. And so I wouldn't totally agree with Arlene. I agree with Arlene on many things, and she is really an amazing force at getting things done. And she's the head of Green Science Policy
right.
Institute. But I think that if you can get rid of your Teflon pans, it's a good idea. Cast iron works, stainless steel works, your old aluminum pans work, and there are several kinds of non-stick pans that don't have PFAS in them. And on the Green Science Policy Institute website, they name some of those manufacturers. And if you go like online to look for their pans, it will say no PFAS, not no PFOA.
Okay. So another question, what drinking water levels do you consider safe? And I think I know where this question is coming from. The city of Madison has actually tested the PFAS levels of all the wells in our city, and they actually closed one of the wells. So the person is saying, which level do you think is safe?
Well, I'd have to know what they tested for. Did they just test for PFOS and PFOA? Or did they
They did PFHXS. They did a panel. Mm-hmm.
They did a panel of like a 10 or 11 or something
Yes.
like that.
Yes.
Yeah.
Mm-hmm.
Well, my recommendation would be you want things as low as possible.
Okay.
Because remember, you're not measuring everything.
Right.
I mean, if somebody would do total organic fluorine in the Wisconsin water, maybe they could tell you, well, this panel that you've measured has measured half of the stuff. That'd be pretty good. I doubt it, but that would be pretty good. So I think the lower you can get it, the better. And I think, as I said, there are a number of states that are looking at a sum of 20 for anywhere from 2 to 6 different PFAS. I should mention that the European Food Safety Authority came out with a regulatory limits for an acceptable weekly intake is what they actually did for the sum of PFOA, PFOS, PFHXS, and PFNA. And it's about 3 parts per trillion, which is quite low. Basically, their recommendation is that certainly nursing infants exceed that level, as well as certain children. Many children may exceed that level as well. So again, I think as low as we can get it. California requires notification of their water supply companies have to notify customers if their levels go over about 10 parts per trillion.
Okay, the questions keep rolling in here. Here's a practical one. What about bathing and doing laundry with contaminated water?
Well, you don't probably have much choice. We do know, for example, that a major source of contamination for firefighters is the gear that they wear when they're firefighting, and they should never bring their gear home and wash it at home, because a lot of the PFAS continuously kind of escapes from the inner layer where it is to provides a moisture barrier, and so that's not a good idea. The levels in a lot of our textiles are, hopefully you're not eating your textiles, but you need to realize, since these chemicals are just added to products, they do escape and get into the dust and so on. So just like we found that when you wash fabrics containing flame retardants, you could find flame retardants in like the dust that you get the lint. You see the same thing with PFAS. So again, you got to do it. You got to wash your clothes, right? You got to shower. There's not much evidence that these chemicals will volatilize heavily in the shower, because they tend to be ionic, so that they will tend to stay in the water.
Okay. So I think I'm going to have to wrap it up, but this question kind of wraps it up. It says, if something is this persistent and harmful to health, why do we leave it up to the consumer to learn about it and sort of protect themselves on their own? And why are we not banning these products?
I have no answer for that, other than, unfortunately, money talks. So, it should not be up to the consumer to make the decisions. But on the other hand, the consumer needs to realize they can be very powerful, and they can bring about change if their governments are not doing it.
Correct. I mean, you brought up the McDonald's thing, right?
Mm-hmm. Right. And Whole Foods.
Mm-hmm. Right. Yeah. Well, I have to apologize to all the questions that are rolling in that I really cannot get to all of them. But at some point we need to end this great conversation.
So I'll take over.
Okay.
Thank you so much, Beth, for fielding those. You're our resident PFAS expert on our team. And thank you, Linda, for sharing so much valuable information, going over time tonight to answer so many questions. And I've tried to copy and paste some of the questions. So maybe I'll be asking you some of them later so we can have them on our website.
I'd be happy to try to answer.
Okay, fantastic. Glad to hear it. And for all of you that are still on, just a quick reminder that WEHN, you can join our email list. We normally send out a monthly newsletter outside of the series, and then you get notifications about events like this that we hold for educational purposes or action alerts. So there is a listserv. Folks can join and get on our list. It's on our website, wehnonline.org. And also on our website, you are more than welcome to donate and support events like this, support our future events, which you can see right there on your screen for the rest of the series and some of our other activities that we do. So again, you can donate online on our website. And then just a reminder, we've got Christine Till on March 11th, and we've got Leo Trisande on March 25th. And they use the same link, but if you have questions, feel free to email us. But I just want to say, Linda, thank you so much. If you have any last words for us.
Well, it sounds like you've got some of my buddies speaking next, knowing Arlene spoke 2 weeks ago, knowing that Christine will give you a great talk about the developmental neurotoxic effects of fluoride. And Leo is actually, and I are actually working together on a project looking at trying to get a handle on the economic costs because of the risks associated with PFAS. So maybe he'll talk about that a little bit.
Great.
Well, final thank you to everyone, and thank you, Linda. We will be ending this meeting, and we'll hope to see everyone in the future.